our third day of working on proofs. Today, we're going to work with a little bit of vocabulary and definitions that we haven't yet used in proofs. Does anybody know what this symbol of an upside down uppercase T means? We've seen it before, Jack. It means perpendicular. And what does perpendicular mean? What does it mean? That's intersecting means they cross. Intersecting, they could cross like that, or they could cross like that. This, though, is not perpendicular. What's the difference? What does perpendicular mean? Wyatt? They cross at 90 degrees. The 90 degrees is what's important with the perpendicular. So our definition, perpendicular, they meet at a right angle. So I could have something like this, and I'm going to give these some names. Maybe this is point A and this is point B, and maybe this is C and D. So maybe somewhere in this problem, maybe it's statement number 1, maybe it's farther down the list, but maybe I am given that AB is perpendicular to CD. So the reason would be given. Then what that means that I could write would be angle ABC and angle ABD are right angles, and that would be definition of perpendicular. So that would be how you would use that statement if you're given that they are perpendicular. Then depending on the rest of the proof, if you actually had triangles here, we've now said that these are both right angles. So then if you needed to, you could go on and say triangle ABC, triangle ABD are right triangles. And do you remember from yesterday what your reason would be for that, Wyatt? Definition of right triangle. And again, this would all depend on what you're actually asked to prove, and we don't have that in this example yet. Excuse me. So our other definition to review, a midpoint is a point that is exactly in the middle between two other points. It's exactly halfway. So if I put some letters on this one, so I'll use X, Y, Z this time. So if I am given Y is the midpoint of the segment XZ, then what I could say sometime after that, I could use the definition of midpoint to say that Y cut this exactly into 2 equal pieces, 2 congruent pieces. So XY is congruent to YZ or ZY, depending on which way I would need it in my proof. Those 2 make sense to everybody? So we're going to do a couple of examples before we go on to the other new things. So let's get this picture copied down on your paper. And draw your statement and reason columns. And remember to write those headings up at the top. Statements, reasons, and we will start writing down the things that we're given. So we are told that angle I is congruent to angle L. That's one of our givens. And we mark that on our picture. We are also told that J is the midpoint of IL, and that's our other given. And so I want you to be a little bit careful whenever you use midpoint and you have something like this. J is the midpoint of IL. It does not say J is the midpoint of HK. It only says J is the midpoint between I and L. So if I want to use that definition of midpoint, since they must have given it to me for a reason, who can tell me what I can say for the statement that goes with that reason? Notice we're looking at the one I highlighted in green. We do not know if J is the midpoint between H and K or not. Ethan? Uh-huh. So IJ is congruent to JL, LJ. I'm not sure which way to write it. So I'm going to check, oh, they tell me a congruency statement, I and then J, and over here, L and then J. So Ethan was exactly right to reverse that and say IJ is congruent to LJ because the J's will end up being corresponding angles. So now I look at my picture. I want to prove congruent triangles, but all I have is one set of sides and one set of angles. So I need to figure out some other things that are congruent with reasons. Griff? So vertical angles right there in the middle, so we can mark those. And our reason will be vertical angles. And is it okay for me just to say angle J is congruent to angle J? No. So on one side, I'll look at the left. I either need to write it down as HJI or IJH. It does not matter for the first one. So I'm going to write angle HJI is congruent to the other side of that vertical angle pair. And then I look at my statement here. HJI means I wrote first, then third, then second letter. So for the other one, I need to take the first, then the third, then the second letter. So KJL. And I'm going to look at my picture. If I start at K, go to J, turn and go to L, is that the angle I wanted to have in there? Okay, now I have two sets of angles and one set of sides. Is that enough? So what do I do, Madeline? Perfect. We're going to say that the other set of angles also has to be corresponding. And our reason for that is going to be angle, angle implies angle, angle, angle. And again, we need to make sure we write the angles correctly. So I can name it any way that I like for the first triangle. So I'm going to say IHJ. I could have said JHI, but I'm going to say IHJ. Actually, I don't think I need to do that, do I? Can I just call that angle H? Because there's only one angle there. That'll make life easier. So I'm just going to say angle H there and angle K. Okay, now I have all of the angles marked on one set of sides. Is that enough to say the triangles are congruent? And Allie, what would be my reason? Perfect. And I will look at the statement the way that they printed it and copy it that way. HIJ is congruent to triangle KLJ. Anybody with questions on that proof? Okay, let's do a second one. So copy this picture. And we're going to get to work with some perpendicular things in this one. So copy your picture, and then we'll get our T-table started for our statements and our reasons. And we'll start with our givens. And pause for a moment while everybody gets caught up to that spot. All right, so I can go ahead and mark those perpendicular angles, but I want to be a little bit careful because I haven't said anything about right angles and right triangles, and depending on which way I prove this, I may need to be able to say I have right triangles. So first I'm kind of going to look at it and think about my strategy, and then I'll back up and start writing things down. I will go ahead and mark PQ and RS on here. So these two left and right sides are congruent. Now I'm noticing my first statement says this line RP is perpendicular to this line PS, which I know means that's going to be 90 degrees right there. And then I know on the other one that when I take RP and QR, that's going to be this one again and this one. If they're perpendicular, that's going to mean this angle is going to be 90 degrees. And I wouldn't really write the 90 degrees on my paper. I'm just kind of thinking through the process. And then I look at, I'm supposed to prove the triangles are congruent. Any thoughts yet about what strategy we're going to use for that? We don't have everything marked on there yet, but first off, for those two triangles, if those are 90 degrees, I could say if I need it that I've got right triangles. And if I think about it that way, are the two sides that I marked legs or hypotenuses? Hypotenuse, so maybe I want to use hypotenuse leg. Somebody had a hand up back here. Abby? For that line in the middle. And so if we do that, would that give us the leg? So are we thinking we want hypotenuse leg? So that means our proof is going to have to say right triangles. We've already got the hypotenuse in there, and we've also got to have the leg in there. So it doesn't matter if we write the leg next or if we go through the things to be able to say we have a right triangle. We have to do them both. Which one do you want to do next? Do you want to do the leg with the reflexive property next, or do you want to get in the proof that we have right triangles? Okay, I heard somebody say we want to get the right triangles in there first. We know we've got these that are going to end up being hypotenuses already listed in there. So instead of that little 90-degree symbol that I wrote in there, I am going to go ahead and put my perpendicular marks on those two angles. Notice they don't go all the way over to the slanty side. They only go as far as the part that makes the right angle. And so I am going to say that I have right angles. And that is going to be, what did we say was our reason? Definition of perpendicular. And then once I have definition of perpendicular, I want to say that my triangles are right triangles. Now I've got to get my letters in there, but I'm just getting the idea down first. I want to say that I have right triangles. And what's my reason once I know I have right angles that I can say I have right triangles? We talked about this one yesterday. Who else remembers? Nicole? So definition of right triangle. So I have to get my letters in the right order. So I'm going to look at this. And you know, this one says PRQ. So that's this angle up here. And R is indeed the vertex. So I'm just going to write it this order, angle PRQ, which means I can also do triangle PRQ. And then the order better match, RPS, since that's also the way it was written here, and I'm going to check over here, is RPS my other right angle? So now I have in my proof that I have hypotenuses and I have right triangles. And Abby, you said what property for the leg? So reflexive property. For this shared side between P and R. So I'm going to write it down either RP or PR first. And so I'll do PR is congruent to, and then I either need to write the other one, PR or RP. I look at my congruency statement up here. PR was letter 1, then letter 2. Letter 1, then letter 2 over here is RP. So I need to switch it around. Because angle R in the left triangle is not congruent to the angle R in the right triangle. Angle R in the left triangle is congruent to angle P in the right triangle. That's where it comes in that we had to do the switch. So now we have hypotenuse, we have right triangle, we have legs. Now we get to say by HL that our two triangles are not just right triangles, but congruent right triangles. So PRQ and triangle RPS are congruent triangles. Anybody with a question there? All right, up to now, we have proven this triangle is congruent to that triangle. A bunch of different ways, a bunch of different kinds of pictures, but we've ended up with congruent triangles. For this one, we ended up knowing, to get to that point, we knew three things. We knew the legs were congruent, we knew the hypotenuses, and we knew one angle, the 90-degree angle, was congruent. Now they're congruent triangles. That means all of the corresponding sides match up and are congruent. Not just the hypotenuse in one leg, but the other leg also. And it means all of the angles have to match up and be the same. Not just the 90-degree angle, but the other two acute angles have to also make matching pairs. That is what we call Cpctc, which you need to memorize and use over and over and over and over in proofs. This lets us say those other sides are congruent for the end of our proof, or those other angles are congruent. Now, what this stands for is corresponding parts of congruent triangles are congruent. But we don't make you write all of that whole sentence out. We let you abbreviate it with Cpctc. We may on a test say, what does Cpctc stand for? And you need to be careful in that case. The first C is corresponding. It is not congruent parts of congruent triangles are congruent. Because if you stop and unpack that and think about the English behind it, congruent parts are congruent. That's redundant. But corresponding parts are congruent, lets you actually do something with it. So that means that you first have to have that the triangles are congruent. So we have to go through those 4 kinds of alphabet soup that we've learned so far for congruent triangles. Then whatever parts you didn't already say in there, you match up. Oh, these 2 correspond, so they are congruent. So then you match up your corresponding parts, and then you can say therefore congruent as the last step of that. So just one more proof, and we'll be done with our note taking for today. Everybody have this down? So copy this picture. Notice on this one, we've put some numbers in here, so I'm going to be able to talk about angle 1 instead of having to write 3 letters, angle QPR. It's just going to let me do a little bit less writing. And once you have that copied, including the letters and the numbers, we can start our T-table, statements, and reasons. And you know by now we're going to start with our givens. And then we need to find those on our picture and mark that they're congruent. So angle 1 and angle 4, I'll do 1 tick mark on those 2. And 2 and 3, I'll do 2 tick marks there just so I can tell them apart. And notice I am not proving triangle congruent to triangle. I want to get a part congruent to a part, but I'm going to need to use Cpctc. So first I do have to say congruent triangles. Then I can say these are corresponding parts, so they're congruent. So that means we need to say these things are congruent triangles. I have 2 sets of sides. I'm sorry, 2 sets of angles. What else can I say is congruent? I'm not sure how many other things I need, but what are some other things that we can say in there? Ada? Sounds good to me. Angle, angle implies angle, angle, angle. We have 2 sets. So the third set also has to work. And those are angle Q and angle S. And then we can come over here and we can also mark that on our picture. So now I have all of the sets of angles. Is that enough? What else do I need? What else can I say is congruent? Cooper? Okay, so I can say this line segment, this side is congruent to itself with the reflexive property. And so I can call that line PR. And I'm not sure if I should write PR or RP for the next one. So I'm actually going to wait a minute and come back to it. I could figure it out now, but then I'm figuring it out again on the very next statement. But now if I look at my picture, am I going to have enough to say that the triangles are congruent? By what reason? So angle, angle, angle side is going to be my next reason. And I am going to say that one triangle is congruent to the other triangle for that reason. So I'm going to just pick whatever order I like for the top triangle. I'm going to say PQR. So angle P, I marked with 1 tick mark in the top triangle, and 1 tick mark in the bottom triangle is the angle at R. So I need to start this second one with an R. I wrote Q in the middle. So I come up here, Q I have 3 tick marks on, and S I have 3 tick marks on, so I do an S in the second spot. And then that means, since I've got R, S, and P in the bottom triangle, and I'm missing a P. I better have a P there. P has 2 tick marks, so does R in the first one, and those are in the same spot. Then it makes it easier for me to fill this one in first, then last PR. First, then last RP. Does that make sense? And I could also say, when I was trying to figure out which way to write that, PR for the first triangle goes from my purple to my green mark. To go from my purple to my green in the bottom triangle, I need to start at R and end with P. Would have been another way I could have thought about getting this order straightened out. Have I said in my proof that these 2 sides are congruent? Let's look at our picture. QR, that's the top. SP, that's the bottom. Have I marked those congruent? I don't have a line in there that says that, but I do have that my triangles are congruent. Are those matching sides? I want to show the top and the bottom. The one on the top is across from one purple tick mark. Is the bottom also across from one purple tick mark? So they are corresponding sides. So I can say that those corresponding parts of congruent triangles, since I've shown the triangles are congruent, are also congruent. And that lets me say that those 2 line segments, the top and the bottom, QR and SP, are congruent. And sure enough, second then third letter, second then third letter. So questions with a Cpctc proof. Don't forget to check what are you asked to show.